Hi, you're here with Mr. Canada, and today we're looking at subtracting in standard form. So the two methods are very similar, identical pretty much to our adding method. So method one, we're going to look at converting them just to ordinary numbers and then treating them like normal, and converting back sometimes can be longer, but sometimes it's just the best method because it's easiest to just subtract big numbers sometimes. Small numbers with decimals, maybe not, just like last time. Method two, we're going to change them all so that they're in the same 10 to the power of n, and then subtract and put them back into standard form. So it would be less of a movement to put them back into standard form. So let's do method one with this question for 5 times 10 to the 4 minus 3 times 10 to the 2. So let's write them in terms of our lower power of n, right? So this is the 2. So that means we have to break this up. So it's going to tell our 5 that's going to become 500 times 10 to the 2. And we're going to subtract off 3 times 10 to the 2. Okay. So really, if you guys want to know the real reason we can always do this is because we can factor 10 to the 2 onto the right, and we can do 500 then minus 3, so we get 497 and times 10 to the 2. But we just don't bother factoring it out because we can just, well, if we just move them over. But that is kind of one of the reasons why. Here, then we can just move back, so we get 4.97 times 10 to the 4. So, pretty easy that way, actually. And I quite enjoy when they're large numbers. So let's do kind of the process that we should do now, because we did method 2 there, right? So I want to do method 1. I wanted to see if you guys would notice if we didn't do the correct method. So here we have 5, and then we go 1, 2, 3, 4. So we have 50,000, and then we're going to subtract off, well, that's 300. So here we're going to get 49700, and then we have to convert back, so we have to move 1, 2, 3, 4, so we get 4.97 times 10, and it's positive 4 because it's bigger than 1. So both methods pretty easy. It's just depending on what kind of maths you like doing. So okay. Method 1 I'm going to actually do on the left hand side this time. So here, let's convert it all. So we have 0. Well, how many times we have to move it? Sometimes it's better just to write it down, even if it's small, out of the way. 1, 2, 3. Okay, so it's 0.004. 1. And then we're going to subtract off. So let's do this one down here too. So, sorry, 2.6. And we're moving 1, 2, 3, 4, 5. So we get 1, 2, 3, 4. So you can remember however many times you move it, you have one less the amount of zeros. There are little tricks, but I would continue on just doing the method I've been showing where you kind of physically show it because there's less chances of making errors. So we have this, right? And now this can be actually quite a handful to subtract decimals. So, because I don't like making mistakes, I am going to set mine up over top of each other. And we have this, correct? So here we have to borrow from there, make this a 0, this turn this to a 9, this to a 10. So we have 10 minus 6 is 4. 5 minus 2 is 3. Oh, sorry, that's not 5, that's a 9. Make sure that if you write stuff, you can at least read your own writing. And then we have 0 minus 0, 0, 4 minus that is 4, and the rest of these are simply going to be zeros. Last step, we have to see how many we have to move. So 1, 2, 3. So 4.074 times 10 to the minus 3. Kind of makes sense because we're not losing this value, right? Because we're only being affected by something quite a bit smaller. So let's do method 2 because last time this is where when we had both negative indices that it kind of paid off to do method 2. So let's get them into our lowest power, which is that -5. Right? So that's going to turn this into 4, 1, 0. Right? And then we'll have minus 2.6. This will all be times 10 to the minus 5. So 410 minus 2.6 is 407.4. And that's times 10 to the -5. Make sure you keep writing that times 10 to the -5, or else you just might forget. And at the end, we just move the decimal place twice. So we write it as times 10 to the -3. As so. I like the method on the right, but you might prefer the method on the left. And as you can see, I want to do this as well for our subtraction, but we know this is not going to turn out very nice. So I'm just going to do it once just to show you that, that you are on the right track, even though it doesn't look nice. Sometimes they throw curveballs in at you. So I'm going to write these out as complete numbers or ordinary numbers. So here we have 1, 2, 3. So we have 0.053, and we're going to be subtracting that from, well, here we're going to get a lot bigger. So 3.65, we're going 1, 2, 3. So here, what are we going to have to do? Well, 3 minus 0 is nothing. 5 minus 0 is nothing. 0 minus 5, that's just negative. So what exactly are we going to get out of this? So we end up just getting negative 3.6447. Okay, and that's times nothing, right? We've already, or sorry, I don't know why I put a decimal in there. That's 365, so sorry. I actually messed up on that one. That's, we move that 1, 2, 3, that's 3650. So 0.0053 minus 3650, and we get negative 3649.9947. And so you notice that it's just, we have values everywhere. So once again, they would tell you that we want it rounded off at a certain value. And then you can put it back into standard form for what you actually be asked for.